going to take a look at a couple different things today. And the first thing is just identifying all factors of a number. Looking at 18, some factors of 18 would be 2 and 9, because 2 times 9 equals 18. Another set of factor pairs would be 1 and 18. And the last one would be 3 and 6. One method that I like is the rainbow method. And what I like about it is it doesn't really allow you to miss any. You start by making the outside of your rainbow with 1 in whatever number you're looking for, like 1 and 18. And then you try 2. So 2 works because 2 times 9 is 18. And then you try 3. 3 times 6 is 18. And so we're only left with 2 numbers in the middle, and 4 and 5 don't work. So you know you're done. That's why I like it. You kind of narrow it down to where you don't have any more choices. And so the factors are 1, 2, 3, 6, 9, and 18. Then what they're asking us to do is to pick out the prime factors. And a prime factor is a number that has exactly 2 factors, 1 in itself. So the only 2 prime factors in this list are 2 and 3, because 2 and 3, 2's only factors are 1 and 2, and then 3 has 1 and 3. 1 is kind of that special one where 1 in itself is still 1. So we don't always consider 1 a prime factor. And then 6, 9, and 18 all have more than 2 factors. So they're called composite numbers. All right, let's take a look at something else. Today what we're going to be talking about is breaking down a number into its prime factors, and there's really 2 methods that Math and Focus shows. And we have the ladder method and we have the tree method, and it really doesn't matter which one you choose. I happen to prefer the tree method, but if the ladder method works for you, then go ahead. One thing to keep in mind when you're doing your ladder method is that you have to put on the outside are prime numbers only. So you can't come up with 2 composite numbers to get it started. You have to have a prime number. So you could start with something like 2 times 30. These 2 numbers multiply together to give you this number. So 2 times 30 is 60. And then we start working with 30. And I say, okay, 3 times 10 gives me 30. And then finally we're down to 10, which has only prime factors. 2 and 5, 2 times 5 is 10. And so what you'll end up with when you go back and you look at the prime factors, if you put a multiplication symbol in between and you multiply them together, you should get 60. 2 times 2 is 4, 4 times 3 is 12, and 12 times 5 is 60. And so at the end, you can always double check by multiplying those prime factors together, and it should give you what you started with. Looking at 60 here, I'm going to choose 2 that aren't prime. I'm going to choose 15 and 4, and that's the reason why I like this method so much. I can just start with any 2 factors. It could be prime, but I'm choosing 2 that aren't. And if they're composite, then I make another branch. And so 15 is composite. I can break it down into 5 times 3. So 5 times 3, 5 and 3 are both prime, so I'm going to circle them and know that I don't add any more branches to that one. And I can also break 4 down into 2 times 2, which are both prime. And so if I list my prime factors again, I'm going to end up with the exact same prime factors, and they multiply to 60. And I wanted to show one more example that students might struggle with. Looking at this, it says given that 320 is 2 times 2 times 2 times 2 times 2. There are 6 2's in a 5. They want us to figure out what 3,200 is without actually doing the prime factor tree. And so what you have to ask yourself is, how do I get from here to here? Well, what I notice is that I have one more 0 here. So what that tells me, if I take this number and I multiply it by 10, I'm going to get 3,200. Now, it would be nice if I could go over here and say, okay, I'm going to add a 10, and now I have 3,200, but there's a little slight problem with that. And the problem is that 10 is not prime. And we're supposed to write this as a product of its prime factors. So all you have to do is go ahead and break 10 into 2 times 5. And now I'm going to go ahead and instead of 6 2's, now I have 7 2's. 1, 2, 3, 4, 5, 6, 7. And instead of 1 5, now I have 2 5's. So I was able to figure it out just by knowing that to get from 320 to 3,200, I multiply by 10. So hopefully this is helpful when completing the homework. Thank you.